What if I told you that right now, hurtling through the cosmic dark of our own solar system, is an object that simply should not exist, something that is actively breaking the foundational rules of physics as we understand them, moving with a purpose that defies all natural explanation? This isn't science fiction. This is happening. We are days away from a moment that could either solve an impossible riddle or shatter our understanding of the universe forever. This is the story of 3I Atlas, the third interstellar visitor ever detected, an object that is doing things that have the scientific community utterly captivated and, in some corners, deeply unsettled. Its tail points the wrong way. It's bleeding chemicals that shouldn't be possible. And one of the most brilliant minds at Harvard has calculated that its very presence here, on this specific path, is so improbable, it might as well be a miracle, or a choice. Let me show you why this silent traveler from another star has become the most compelling and controversial object we have ever witnessed in the heavens, and how its mysteries might just hold a mirror up to our own lives, forcing us to ask questions we never thought to ask. We begin with the most glaring, the most impossible, the most flagrant violation of cosmic law, the tail that defies gravity. To understand how profoundly bizarre this is, we first need to appreciate the simple, elegant physics of a normal comet. Imagine a comet as a dirty snowball, a loose clump of ice, dust, and rock forged in the cold, outer darkness of a solar system. For billions of years, it tumbles through the void, frozen and inert. But as its long, looping orbit brings it closer to its star, the Sun, something beautiful happens. The star's energy begins to warm its surface. The ice doesn't melt into water. In the vacuum of space, it sublimates, turning directly from solid to gas. This outgassing kicks up dust and rock from the comet's nucleus, creating a glowing cloud around it called a coma. Now, the Sun is constantly emitting two powerful forces. The first is solar radiation, the sheer pressure of sunlight itself. The second is the solar wind, a relentless stream of charged particles flowing outward from the Sun at over 1,000,000 miles per hour. These two forces act like a celestial hairdryer, pushing against the gas and dust of the coma. The result? A tail. Or more accurately, two tails. A brighter, slightly curved dust tail, and a fainter, straight ion tail made of gas. And in every single one of the thousands of comets we have ever observed, without exception, these tails point in one direction, and one direction only: away from the Sun. It's a fundamental rule. The tail is a cosmic windsock, always showing the direction the solar wind is blowing. It's as certain as gravity itself. Then came 3I Atlas. In August of 2025, when the twin telescopes perched on the volcanic slopes of the Canary Islands captured their first clear images, astronomers saw something that made them check their instruments, run their calculations again, and question their own eyes. There, streaming from this interstellar visitor, was a tail of gas and dust approximately 3.7 miles long, but it was pointing the wrong way. It wasn't pointing away from the Sun, it was pointing directly at it. Let that sink in for a moment. This object was spewing a massive trail of material in the exact opposite direction that physics dictates. It's like throwing a ball into the wind and watching its trailing ribbon fly back into your face. It's like a ship's wake forming in front of the bow. It's an impossibility. They've given it a name: an anti-tail. Now, some very specific, rare geometric alignments can create the illusion of an anti-tail from our perspective on Earth, where heavier dust particles left behind in the comet's orbit can appear to point toward the Sun. But this wasn't that. This was an active stream, a jet of material being ejected against the full force of the Sun. Professor Avi Loeb, the former chair of Harvard's Astronomy department, a man who is no stranger to controversial ideas, was one of the few scientists willing to publicly confront this anomaly head-on. While many of his colleagues, as he noted, were content to ignore this detail, to file it away as a curiosity while insisting the object must have a standard origin, Loeb argued that this orientation doesn't match any known mechanism of cometary degassing. He saw it not as a curiosity, but as a clue, the first piece of a much larger, much stranger puzzle. And this brings us to our first practical link, our first lesson from this visitor. How often in our own lives do we encounter an anti-tale, a fact that doesn't fit the story we're being told, or the story we tell ourselves? It could be in a relationship where someone's words say one thing, but their actions point in the exact opposite direction. It could be in a business plan where the data on the spreadsheet points to success, but a gut feeling, an undeniable anti-tale of evidence, points toward failure. Society, our peers, and even our own brains are built to favor the standard model. We're comfortable with the tail pointing away from the sun because that's the rule. It's easy. It's predictable. When we see something that defies that rule, our first instinct is often to ignore it, to explain it away, to call it an anomaly and move on because the alternative, the possibility that the rule itself is wrong, or that we're not looking at what we think we are, is disruptive. It's uncomfortable. It forces a paradigm shift. 3i Atlas teaches us to pay attention to the anti-tales. It advises us not to dismiss the data that doesn't fit. That single impossible detail is often the key that unlocks a deeper truth. What is the anti-tale in your life right now that you might be ignoring? What established rule is it challenging? Perhaps it's time to stop looking where everyone else is looking and instead turn your attention to the thing that's pointing the wrong way. But this impossible tale was just the beginning. As astronomers trained more powerful instruments on 3i Atlas, the anomalies began to pile up, forming a pattern that defied not just physics, but chemistry and statistics as well. An object can have one strange characteristic and still be natural. Two is intriguing. But when you get a whole collection of statistically improbable traits in a single object, you have to start questioning your foundational assumptions. And that's precisely where the story of 3i Atlas takes us. Let S move to the second piece of the puzzle. The chemistry that shouldn't exist. When spectroscopes analyzed the light coming from the object's coma, they found something that sent a shockwave through the astrochemistry community. They detected nickel. That in itself isn't terribly strange. Heavy elements are found in comets. But it was what was missing that was so bizarre. There was no iron. To understand why this is so chemically implausible, you have to understand where heavy elements come from. They are forged in the heart of dying stars. In the unimaginable heat and pressure of a supernova explosion, lighter elements are fused together to create heavier ones. Nickel and iron are cosmic siblings, born in the same violent crucible of star death. They are almost always found together in meteorites and other celestial bodies, typically in predictable ratios. Finding nickel without a corresponding amount of iron is like finding a forest of trees with no roots. It suggests some process has occurred to artificially separate the two. It's a chemical signature that has no known natural precedent. It's as if something, somewhere, was refining metals, preferentially selecting nickel and ejecting it into space. This leads directly to the third anomaly, perhaps the most mind-bending of all: the sheer improbability of its trajectory. Professor Loeb and his team at Harvard didn't just look at the object, they looked at its path. They calculated the odds of an interstellar visitor entering our solar system on this specific course. The solar system is a tiny target in the vastness of the Milky Way galaxy. An object cast off from another star billions of years ago would have an almost infinite number of possible paths. The calculation took into account its entry angle, its velocity, and its inclination relative to the plane of our solar system, the flat disk where all the planets orbit. The result of that calculation was staggering. The probability of 3i Atlas arriving on this particular trajectory by pure chance was just 0.2%. That's 1 in 500. To put that into perspective, imagine a friend standing on the Golden Gate Bridge in San Francisco, and you're standing at the base of the Statue of Liberty in New York. Your friend throws a single grain of sand off the bridge, and by pure chance, the wind carries it across the entire continent, and it lands perfectly on the tip of your outstretched finger. That is the level of improbability we are talking about. It's statistically possible, yes, but it's so unlikely that it begs the question, was this a random shot in the dark, or was it aimed? Was this chance, or was this navigation? Now let's step back and look at the full picture, the pattern that can't be ignored. Individually, these anomalies are puzzling, but together, they form a narrative. We have an object with an anti-tail pointing toward the sun, defying physics. It's ejecting refined nickel without its sibling iron, violating chemistry. It's on a trajectory with a 0.2% natural probability, defying statistics. And there's more. The object is estimated to be ancient, perhaps 7 to 10 billion years old, older than our own solar system, yet it's still active. It's moving faster than typical comets. Observers have described its shape as unusually cylindrical, a form rarely seen in nature, but common in engineering, and it managed to navigate past the gravitational fields of Venus, Jupiter, and Mars, while remaining largely undetected from Earth until relatively recently. As Loeb argues, this pattern is more consistent with technology than with natural processes. Nature can produce one or two coincidences, but for nature to pull off this entire series of statistically impossible feats in a single object? That strains credulity. We're either witnessing a series of cosmic miracles, or we're looking at something that doesn't fit the natural model at all. Herein lies the second profound lesson from our silent visitor, a lesson about critical thinking and the power of patterns. In our daily lives, we are constantly bombarded with information, with isolated data points. A single strange comment from a friend, an odd expense on a company report, a fleeting feeling of doubt about a decision. It's easy to dismiss these as one-offs, as statistical noise. We compartmentalize them. We say, "Oh, that was just a weird day," or "that must be a typo." But 3i Atlas teaches us to be pattern seekers. It urges us to connect the dots. One anomaly is a data point. A collection of anomalies is a story. This principle is the foundation of every great detective story, every groundbreaking scientific discovery, and every insightful personal realization. It's about not just seeing the trees, but recognizing the shape of the forest. When you start seeing a pattern of inconsistencies in a relationship, in your health, in your career, it's a signal that your initial assumption, your natural comet explanation, is likely wrong. The pattern is telling you there's a deeper truth you need to uncover. The universe, and our lives within it, are not always what they seem on the surface. Don't ignore the nickel without iron. Don't dismiss the 1 in 500 trajectory. These aren't just oddities. They are signposts pointing toward a different reality. What patterns in your life are you currently dismissing as mere coincidence? What might they be telling you if you dared to connect them? This brings us to the climax of the observational campaign, the moment where all theories and speculation will be put to the ultimate test. The scientific community has a date circled on its calendar, October 29th. This is the object's perihelion, its point of closest approach to the Sun. For 3i Atlas, this is its moment of maximum peril and maximum opportunity. It's the point of no return. If this object is, as most scientists maintain, a natural comet, this is the moment it will likely meet its end. The thermal stress will be unimaginable. The Sun's heat will penetrate its nucleus, vaporizing not just surface ices, but also volatile materials deep inside. This will create immense internal pressure seeking escape. For a fragile object like a comet, a loose agglomeration of ice and dust held together by little more than weak gravity, this pressure is a death sentence. It will crack the structure apart. We've seen this happen countless times. Comets like Ison and C2020 F3, Neowise, have fragmented or disintegrated under the strain of a close solar pass. It's a predictable, well-understood process. We'll see a sudden brightening as the nucleus breaks apart, exposing fresh ice to the Sun, followed by a slow fading as the debris field disperses along its orbit. If this happens, the debate ends. 3I Atlas will be classified as a comet, albeit a very strange one. The anomalies will be explained away as rare but natural occurrences, and the book will be closed. But what if it doesn't? What if October 29th comes and goes, and 3I Atlas emerges from the other side of the Sun intact? What if it endures the inferno? This is where the story shifts from a scientific curiosity to something far more profound. If it survives, it strongly suggests the object is not a fragile, dirty snowball. It implies it is something far more robust, either incredibly dense and cohesive, like a solid chunk of rock or metal, or that it is structurally engineered. A natural comet simply shouldn't be able to withstand that level of stress. This is where Loeb's alternative scenarios, including the explosive idea of technological origins, become much harder to dismiss. The survival of perihelion would become the single most powerful piece of evidence that we are dealing with something outside of our known categories. Furthermore, this date is crucial for another reason. For an object under intelligent control, perihelion is the optimal point for a gravity assist maneuver. By firing an engine or venting propellant at precisely the right moment, a spacecraft can use the Sun's immense gravity to slingshot itself, dramatically altering its speed and direction, to set a new course for its next destination. Any civilization capable of interstellar travel would understand this basic principle of orbital mechanics. They would plan for it. And here's the kicker. This maneuver would happen when the object is on the opposite side of the Sun from Earth. Our view would be blocked. Our ground-based telescopes would be blinded by the Sun's glare. If something were going to happen, if it were to change course, deploy smaller probes, or reveal its true nature, this is the window when it could happen largely undetected. The timing is almost too perfect. This moment of truth for 3I Atlas is a powerful metaphor for our own lives. We all face our own perihelion passages, moments of extreme pressure, stress, and trial. It could be a major career challenge, a personal crisis, a health scare, or a difficult confrontation. These are the moments that test what we are truly made of. Under that heat, do we fragment? Do our convictions, our relationships, our sense of self break apart under the strain? Or do we hold together? Do we prove ourselves to be more robust, more resilient than anyone, including ourselves, thought possible? A perihelion passage, for a comet or a person, is revelatory. It burns away the superficial layers and exposes the core. It reveals our true structure. It's in these moments that we discover our own strength. And just like 3I Atlas, it's often in these moments of intense pressure, when we feel most overwhelmed and unobserved, that we have the greatest opportunity to change our trajectory. We can use the gravitational pull of the crisis to slingshot ourselves in a new direction, with new purpose and new velocity. The question 3I Atlas poses to us is this: when your moment of maximum stress arrives, will you break apart, or will you emerge from the fire intact on a new and deliberate course? Your answer to that question defines your character. As the countdown to perihelion continues, scientists are digging deeper into the chemical enigmas of this visitor, and what they're finding only adds to the unsettling nature of the puzzle. Let's revisit one of the most baffling aspects: the water. In October, the Swift telescope detected an enormous stream of water vapor pouring off this object, approximately 40 kilograms every single second. To help you visualize this, imagine 40 large 1-liter bottles of water evaporating into space every single second. That's 2,400 liters per minute. That's enough to fill an average swimming pool in a day. It is a colossal rate of outgassing. But here is the problem. 3I Atlas was, at the time of this measurement, about 3 astronomical units, AU, from the Sun. That's 3 times the distance from the Earth to the Sun, roughly 450 million kilometers away, out in the cold expanse of the asteroid belt. At that distance, the Sun's energy is only about 11% as strong as it is here. It's barely enough to warm ice, let alone vaporize it at such a massive rate. Normal comets are largely dormant at this distance. They don't start producing significant water vapor until they get inside 2 AU, a region sometimes called the snow line. For this object to be blasting out this much water from a distance where it should still be frozen solid is a profound violation of thermodynamics. The physics just doesn't add up. The energy budget is completely out of balance. What is powering this? Some have suggested subsurface heat from the radioactive decay of elements within its nucleus. But for an object billions of years old, most of its short-lived radioactive fuel would be long spent. The numbers don't work. The sheer volume of water remains a deeply unsettling mystery. And then there is the even stranger chemical clue, a detail that barely made headlines, but is perhaps one of the most compelling technosignatures ever detected: the appearance of nickel tetracarbonyl. Spectroscopic data revealed the presence of NiCO, a compound where a single nickel atom is bonded to 4 carbon monoxide molecules. This is not some common, naturally occurring molecule you find floating in space. On Earth, nickel tetracarbonyl is a man-made industrial chemical. It's used in processes like the Mond process for refining nickel to an extremely high purity. It's toxic, it's volatile, and it only forms under very specific conditions of temperature and pressure when metallic nickel reacts with carbon monoxide. To find this in the coma of a comet is bizarre. To find it in an interstellar object that is already inexplicably ejecting nickel without iron is beyond strange. It's as if we are seeing the exhaust fumes from an onboard industrial process. It suggests that somewhere inside 3I Atlas, there is pure metallic nickel reacting with carbon monoxide-rich gases. It's a chemical signature that screams of artificiality. Could this be the key to the missing iron? Perhaps there is a mechanism inside this object that is isolating and concentrating nickel, forming compounds like nickel tetracarbonyl for a specific purpose, leaving the iron behind, locked away in a different mineral structure. It is highly speculative, of course, but it's one of the only ways to reconcile the impossible chemistry we are observing. The alternative, that nature spontaneously created an interstellar object that perfectly mimics a 20th century industrial refining process, seems to some even more fantastic. This is a lesson in looking for the fingerprints. When trying to understand a complex situation or a person, we often focus on the big, obvious behaviors, the comet's brightness, its overall path. But the truth is often hidden in the trace elements, the subtle chemical signatures that seem out of place. The presence of nickel tetracarbonyl is like finding a modern Phillips head screw in an ancient Egyptian tomb. It's an anachronism. It's a fingerprint that tells you a different story is at play. It forces you to reconsider the entire context. In our lives, these industrial compounds can be subtle linguistic tics, unusual emotional reactions, or behaviors that are inconsistent with a person's professed character. They are the small, out-of-place details that, once noticed, can reveal a hidden process, a hidden motivation, a hidden truth. The universe, and the people in it, leave behind chemical trails. The lesson from 3I Atlas is to become a forensic observer in your own life. Pay attention to the trace evidence. Don't just listen to what is being said. Look for the compounds that don't belong. They are often the most honest messengers. All of these anomalies, the anti-tail, the improbable trajectory, the impossible chemistry, have led Professor Loeb to formulate a structured, albeit radical, explanation: the mothership hypothesis. This isn't just a wild guess. It's a conclusion based on the data, an attempt to find a single theory that elegantly explains all the anomalies simultaneously. Loeb suggests that 3I Atlas could be a large, ancient, and possibly autonomous craft sent by an extraterrestrial civilization billions of years ago. In this framework, the pieces of the puzzle suddenly click into place. The reported cylindrical shape makes sense for a constructed object. The anti-tail is no longer a physical impossibility, but could be a form of propulsion exhaust or a directed energy system. The bizarre ejection of pure nickel and industrial compounds could be byproducts of onboard processes, perhaps maintenance systems, energy generation, or resource extraction. The massive outgassing of water could be the venting of coolant or waste from a functioning system. The 0.2% probability trajectory is no longer a lucky shot, but an intelligently planned course designed to survey our solar system. The object's immense age and resilience are consistent with a probe designed to survive for eons, hopping from star to star. Loeb even takes it a step further. He speculates that if this is a mothership, its primary mission upon entering a new star system might be to deploy smaller, stealthier probes, scout craft that could separate and remain behind to observe planets and moons long after the parent craft has departed. These smaller probes would be far too small and faint for us to detect with our current instruments. The mothership would use the Sun for a gravity assist and continue its journey to the next star on its list, leaving behind silent watchers. We would be left with no evidence of their presence, unless they chose to be found. It's a scenario straight out of classic science fiction. But Loeb argues that it is a hypothesis that fits the observed facts more neatly than the natural comet model, which requires us to accept a whole string of unrelated, statistically improbable miracles. He is not saying this is an alien probe. He is saying the possibility should not be dismissed out of hand simply because it is uncomfortable. The data, taken as a whole, demands we consider it. And as we approach the final countdown to October 29th, we are left with this stark choice. Are we witnessing a one-in-a-billion natural wonder? Or are we about to get a fleeting sideways glance at something that will change the course of human history? And so we arrive at the end of our story, but at the beginning of a profound moment of discovery. The journey of 3I Atlas, this silent messenger from a distant star, serves as one of the most powerful allegories for the human condition that I have ever encountered. It teaches us a final, crucial lesson: the importance of intellectual courage. Look at the position of the mainstream astronomical community: cautious, quiet, clinging to the standard model because the alternative is too disruptive. This is a natural human tendency. We build our careers, our worldviews, our identities on existing paradigms. Challenging them is risky. But then look at Avi Loeb, a man at the pinnacle of his profession, willing to stake his reputation on an unpopular, fringe idea, because that is where he believes the evidence points. That is intellectual courage. It's the willingness to follow the data, even if it leads you to a place where you are ridiculed or ostracized. It is the spirit of Galileo, of Copernicus, of every great mind who dared to say, "But what if we're wrong?" This is the ultimate advice that 3I Atlas offers us for our daily lives. Have the courage to be the Avi Loeb in your own story. Have the courage to question the Manin standard model of your own life, the assumptions you hold about yourself, about others, and about the world. Be willing to entertain the mothership hypothesis for your own potential. What if you are capable of more than you believe? What if the trajectory you are on is not a random path, but one you can intelligently navigate? It requires you to look at the anomalies, connect the patterns, withstand the pressure, analyze the hidden evidence, and finally to formulate a hypothesis about your own life that might seem radical, but is consistent with all the data of your own experience. It's about having the courage to face the universe and yourself with open-minded skepticism, ready to be proven wrong, but unafraid to explore the possibility that we are living in a far more interesting, mysterious, and populated reality than we ever dared to imagine. As we wait for the final verdict on 3I Atlas, I want to leave you with a few questions to ponder. What is the biggest anti-tale in your life? The most glaring piece of evidence that contradicts the story you've been telling yourself? What improbable patterns have you been dismissing as coincidence? And what would it mean for you, for your future, if you started to believe that your path through this world wasn't just a random walk, but a trajectory that could be navigated with intelligence and purpose? Whatever the truth of this visitor may be, its journey has already given us a profound gift. A reason to look up, to wonder, and to question everything. Thank you for joining me on this exploration into the heart of one of the greatest cosmic mysteries of our time. I truly hope you and your loved ones are healthy, happy, and safe. May you always keep your curiosity pointed toward the stars. If you found this journey as captivating as I did, and you want to continue exploring the biggest questions in science, philosophy, and the human experience, please consider subscribing to the channel. Your support makes all of this possible. Until next time.